Okay. Good morning, good afternoon. Welcome to the special session ISQGD SS13 on ancient Indian mathematics, organized by the International Society in Quantization, Geometry and Dynamics. The ISQGD is an international society dedicated to advancing research and collaboration in mathematics and interdisciplinary sciences. I am pleased to inform you that a special issue on the theme Ancient Indian Mathematics is being planned in the ISQGD Journal of Quantization and Dynamical Systems. The deadline for submission is 30th July 2026. We warmly invite your contributions and look forward to your participation. Now let me introduce today's first speaker, Dr. Mahesh Sahebrao Vavre from Rajarshi Shahu Mahavidyalaya, Latur. The title of his talk is Ancient Indian Mathematics, an integrated view of numeral systems, geometry and number theory within the IKS framework. Now it is over to you, sir.
Okay, thank you, sir. Sir, just now told about my topic. This is the general outline of the topic, the overview of Indian knowledge system, and as well as significance, as well as sources, the chronological mathematicians information, earlier number systems, geometry in Sulba Sutras, Brahmagupta geometry, Indian numeral system, how arithmetic operations defined by the earlier mathematicians. If time permits, this Kutaka and Varga Prakriti, the Pell's equations will be discussed here. So, ancient Indian mathematics, we talk about first about Indian knowledge system. The traditional body of the knowledge developed in India over thousands of years ago, which includes mathematics, arts, language, science, astronomy, medicine. All those things were discussed. Especially, we are focusing on ancient Indian mathematics also. So, mathematics initially developed as a part of astronomy and the religious literature. Later on, it came as a part of mathematics. I remember when Sapnil was my colleague at Rajesh Shaw College, Latur, during the visit of NAC. He have put some important Sanskrit sloka in our board. It was still there. Yatha Shika Mayurana Nagana Manayo Yatha Tad Vedanga Shasana Ganit Murdani Sthitam. The meaning of this slok is like the crest of heads of peacocks, like the gems of cobras. The mathematics, earlier it is known as astronomy, is the top of all Vedaganga Shastras, and it is there in Yajus Vedaganga Jyotish 4. Ancient Indian scholar developed mathematics initially to support discipline like astronomy. It was initially astronomy, architecture, and some religious rituals. This dual nature, intensely practical yet highly poetic, birth foundation arithmetic, algebra, geometry centuries before they appear in the West. So this is about Jyotisha. Earlier it was astronomy. Later it came into picture as mathematics. Some sources of mathematics. Also, I must told you about what important topics include in the Indian knowledge. These includes Parikarma means the four arithmetic operations. Raju stands for geometry. Rashi. There are so many involved there. Like Yavat, that is simple algebraic operations. Then Ghana and Ghanamula, you may call it as cube and cube root. Varga Vargamul, square and square roots. Kal Savarna, it is also known as the fractional or rational part of that numbers. Later on, Mahavira discussed about Prastar and Vikalp, that you know as permutations and combinations. The significance of these sources, Brahmagupta, 0 as number he mentioned there, and it available in the Sulva Sutra. Sulva Sutra is the very earlier text available here. Aryabhatiya Lilavati. Also, India has given decimal place value system. Then they give constructive proofs and algorithms. as oral traditions or verses. They mostly use the Sanskrit language for that. Later on, these texts were translated into Arabic and then Europe. Some foreign account as Al-Biruni, the Al-Qaziri, in during 800 and 800 to 1300 C. You can see later on. Okay, this is the development of Indian mathematics as chronological from 800 BC to 1920. That is the era of Ramanujan, 1920. You know the well mathematician Ramanujan. As I told you that Sulabh Sutras are among the earliest mathematical texts in India. They are found as a part of Vedic literature. This text gives you rules for constructing Vedic ultras using the ropes and include ideas from geometry. The Pythagorean theorem appears here also. Pythagorean, we know the great mathematicians. Before that, these Pythagoreans, that Koti Bhuja theorem is the name of that. The Pythagorean is Greek mathematician. The Sulabh Sutra also discuss the methods of squaring circle, showing early development in mathematical thinking. The text also provides approximate values of the irrational number like root 2. So you can found this ritual geometry, rope measurement, and Pythagorean concept during 800 to 200 before Krish area. Later on, Pingala. I am audible, sir.
Yes, yes, sir, you are audible. Go ahead.
Sometime I message come that you have unstable network data. I am at my native
Okay,
place. Maybe
okay.
because
I will remind you. Yes, sir.
okay. Pingala is duration 200 BC. He have written Sanskrit prosody, the study of poetic matters. In the form of poetry, he have given all the things, just like we have seen the sloks in the Sanskrit, like that. His work, Chad Shastra, about the binary number system used now today in modern computer. The Pingala have given the binary number system. He used dot for zero. Later on, the Bakshali presently the village situated at Pakistan. The Bakshali manuscript, I have one screenshot of the Bakshali I will show you later on. The earliest symbol of zero and fractions and equations were discussed in the Bakshali's manuscript. Bakshali is the name of village. It's situated in now Pakistan. Later on, Aryabhatta 476 C to 550 C. Aryabhatta was one of the greatest Indian mathematician and also astronomer. His famous book Aryabhatiya covers the arithmetic, algebra, plane geometry, spherical trigonometry, and astronomy. Later on, Brahmagupta, Aryabhatta gives the decimal. Aryabhatta finds the pi value for four decimal places. He prepared the sign table for 24 values. As he is astronomer, he have developed the spherical astronomy also. He also proved that in the astronomy, he also proved that the rotation about the Earth. Later on, Aryabhatta's work continued by the Brahmagupta. He have Brahmagupta also mentioned the law of composition that we use now in group theoretic. The law of composition given by Brahmagupta. He mentioned the rules for addition, that is plus plus is plus for multiplication, rules for zero, rules for negative numbers, and he have studied in the algebra. This is about the Brahmagupta's era. Later on, the Kerala from the Kerala school, the Madhava is the great mathematician. In the name of Madhava, India, through the NBHM, we have the Madhava Mathematics competition for secondary UG students also. Madhava gives the foundation for the calculus. He also studied infinite series. He gives the value of pi in terms of infinite series. He have defined sine and cosine series. The Kerala school, later on, in the Kerala school, Madhava, later on, other mathematician also gives that Madhava of Sangam Rora place is that. And the Nilkantha, Somyaji, and Deva improved his earlier ideas. And in the still the Kerala School of Mathematics, that is Matwa School, is there in the Kerala. If somebody wants to visit, you can visit in that school. And in the modern era, everybody knows about the contribution in the 20th century about Ramanujan, what he did, his major contribution in number theory. He gives partition functions and their intuitions were good. So this is the chronological overview of the development of Indian mathematics. The slide is not moving next.
Maybe that some request is visible that you need to say no thanks or
Wait, I have. Okay. That editor option has been on. Now, as per the numeracy matrix, how ancient India encoded the data. Modern decimal system, as you know, for the decimal system, we use the 0 to 9 number. These are the abstract symbols for representation number. This decimal system given by our Indian mathematician. So earlier it was their Bhuth Sankhya system and cut-off ID system. Cut-off ID is just like of the coding. Some alphabets, Devanagari alphabets, they have given the values for that. So in a both Sankhya systems, like you see, the moon is single. So to represent one, they use moon. They use netra or bahu to represent the symbols for two. Earlier, the symbol like 1, 2, 3 was not mentioned. Like we have two eyes, two hands, like that. Two for bahu, netra, bhuja, like that symbols were used. Then for three, they, like Shankara's third eye is mentioned, Agni was there. For three, Agni was there. Like that, symbols were discussed in the Bhut Sankhya system. They are written in the poetry form, in the philosophical nature, and they like number you read from our numbers you read from left to right. Here in Bhut Sankhya system, they read from right to left. Okay. In the Katapidi system, the mechanism for that use was the Devdagi script like K, K, D, G, J, and all these alphabets were there. And for that 1 to 9, all those number mentions. Like I have example is not mentioned here. For P it is 1, for G it is 2, for D it is 3. Like that K, T, P, Y, that letters were represented for 1, K, K, T, P, R, that letters were represented for 2, and so on. And the vowels are free, that vowels are for zeros. The Katapidi system used for the music and astronomy, and they also refer for left right. So these are the two systems used in the earlier. And later on, Indians have used the decimal value system that in the powers of tens, and this is very big, big contribution of India to the world. Now, as for the Roman part or Greek part concerned, earlier Roman numerals were used. You can see, you can add on, subtract maybe easily, but while the part of division and multiplications, you can think about how multiplication and division will be possible by the using of raw number. You can think. So limitation of Roman number is about now. If you continue, if you compare with the decimal value system, it is up to 10 raised to 3. For the Greek period, it is up to 10 raised to 4. But when you go for ancient India, in Taittiriya Samhita, about 200 before Christ era, you see that 10 powers are mentioned. Up to Parar the numbers were given. As per the Jain cosmology, it was up to 10 raised to 140. So these numbers were given by the Indians. You can compare the Roman numbers or Greek myriad. with our Indian digit. So that earlier I have told that in earlier construct, the Booth Sankhya, how the mapping of digits to objects were given elements to the idea. That like one Bhumi, that is one Earth, one Moon. So there was not symbol like one. The later on symbols were given. There is history about symbol also. So Moon, that single things, that unique things is represented by one. Zero for shunya or void or sky, just like sky is empty. Sky is, there is no limit for that. They use akash. In English, it is sky for zero. Two netras, for netra there are two eyes, two bahus. So two netras, for netras and bahu, two symbol is mapped. Four Veds were there, so for Veda, for text, that four Vedas are there, so four number is for that. Agni fire, you can see the third eye of Shankara for representation of the Agni, and so on. Rasa for 6. The words were arranged right to left. The final words spoken represented the largest power of 10. This is the Booth Sankhya system. If I have given example of that, I will show you. Okay. Example is there. So Booth Sankhya mechanism, meaningful words directly linked to the objects or idea in the nature. So this Sanskrit slok you can read. Ras gun purna mahis sma shakruna pase bhavna stuti. So ras for 6, guna for 3, purna for 0, and mahi for 1. So meaning of that is from that Sanskrit verse, the Bhaskaracharya's birth year is 1036, that is 1114 C. It also states that he wrote Siddhanta Shiromani at the age of 36, Rasguna Varshe. That is, you have to consider its age as 1150. Similarly, Aryabhatta provides his birth year in Aryabhatiya as follows. That you can read that Sanskrit. And there were these were symbols, like I mentioned that 32 there are dantas, that teeth are there, 27 nakshatras were there, 33 koti deva, you use the word that all those numbers were discussed in this Bhuta Sankhya system. Like Katapidi also I have discussed earlier. So this is the phonetic cipher for Katapidi system. I told you that Katapaya one, that symbolic representations, and here vowels have zero numerical value. So this is Katapidi numerical system. It has applications. How the values of y given in the Sanskrit slope. This Sanskrit slope is given, and you have to read it from right to left. So this is 17-digit value of pi given in the Baksari manuscript in both Sankhya system. Applications found in the calculating of music. Now we move for the geometrical part, the science of shapes. Before pre-Aryan period, that is 2500 BC, these photos I have taken from internet. These are the shapes or circles or triangles, curved lines used as tools or boards. You can see that. In the Vedic or Sulba Sutra periods, the religious geometry's method to construct squares, rectangles, and approximate value of square root 2 for sacrificial fire pits. And the post-Christian period, the abstract mathematics, astronomy, spheres, trigonometry, sine functions, that is, sine functions are known as ardhaja, and the planetary motions. The religion of precision, that is Sulba Sutra. I told you that the Sulba Sutra is the earliest text available here. Sulba means Raju, Sulba means measurement of ropes. In the geometry, it was just known as science of ropes. The ultra requires exact areas and flawless shapes. The mathematical error in the bricking was viewed as equivalent to the mischanted religious mantras. So they are very particular about the size and shapes of. In that construction, this ultras constructions, the geometry of mathematics were used. This is falcon shape altar that is known as Shayan Chitti, built using 5 complex layers of the bricks, totaling exactly 1000 bricks and precisely arranged to represent the bird of prey. I told you that about Pythagoras. The Bodhyana have already mentioned in his sutras. It is known as Bodhyana Pythagoras theorem here now. The sutra is Bhuja Koti Karni Nyayam. It's in the Sanskrit. So meaning of that statement is that it was stated around 800 BC, long before Pythagoras. The fundamental theorem of right angle triangles was understood through the practical geometry of ultra constructions. It was observed, not specially mentioned, but in the ultra construction it was observed. It is Sanskrit slope for that. So when you consider right angle, you know the Pythagoras theorem, right angle triangle, the square of two sides is equal to the sum of square of two sides is equal to the hypotenuse square. Brahmagupta's theorem for the rational constructions in quadrilateral constructions. In a cyclic quadrilateral, if sides are ABCD and diagonals are XY, these diagonals are calculated by using this. And this example is mentioned here. As per the Aryabhata's span was 476 to 550 CE. Aryabhatta gives the formula for area of right angle triangle, that is half base into height, is found in his literature. He also gives the intersecting chord theorem, that is AM into MB equal to MC square. The proofs were available in his literature. Later on, Mahavira, his span 815 to 870 C, he gives first general formula for the combination NCR. He also mentioned the formula for permutation also. He compute the ellipse circumference approximation given by this formula. And also you can find in the Ramanujan's work, Ramanujan also mentioned the circumference of this ellipse approximately equal to this value. Now we come to the number systems. How earlier it was no proper symbol given to the 1, 2, 3 like that. There no symbol were given. So features of good numeral system: it should be small number of symbol. It should be rememberable. Ability to write very large number also. And the decimal system you can see, we can write very large number by using of decimal place value system. And it should be very easy calculations. Like you consider the two, I have written the numbers in decimal form. But if you think that 4321 is Roman number and 2025 is also Roman number, and if this value system, decimal value system, is not known to us, then it is very hectic to calculate the product of this. Because why Greeks were not focused about this? The Greek, you can see the Greek were focused only on geometry. They are not involved in much more part of arithmetic algebra. So here I want to again mention that India's contributions about decimal place value system and invention of zero as symbol and number, zero as symbol and number. So regarding Aryabhatta mentioned for empty place as Kha. Yoga Bhasha during 4th and 5th BC, a single stroke can represent 1, 10, 100,000 depending on its place. Baksali manuscript, I have mentioned the screenshot of Baksali here. He mentioned dot for 0. Baksali place is now situated in Pakistan. Brahmagupta gives formal rules for 0 as a number. He mentioned that sum of 2 positive is positive, sum of 2 negative is negative. Although it looks simple, but that period it is very important to think about it. Sum of 2 positive and negative will be the difference 0 if equal, otherwise you know what sign you have to put that larger number. 0 plus negative is always negative, positive plus 0 is always positive, and 0 plus 0 is 0. All those rules were stated by Brahmagupta. He also gives rules for subtraction, multiplication, division with 0 and negatives. He also mentioned about square roots, square root for positive numbers, and it has two values, plus or minus. In his article, only division by 0, he mentioned the error. Later, Madhva, that Kerala school, mentioned that division by 0, what was the error. And this screenshot is attached for present in Baksali's manuscript. The dot is represent for 0. Brahmi, near about 300 BC, he used symbols 1 to 9, but he doesn't use zeros there. You can see this is the Ashok Pillara's Gupta's numerical system. Also, Chaturbhuj temple, Gwalior in 9th century, 0 as small circle is mentioned there. I have mentioned here. See here, 0 as small circle. How this decimal value system spread out of the India. During 800 C to 1200 C, Al-Fazari, Al-Khwarizmi, all Arabic mathematicians came into India. They translate the Brahmagupta's work into Arabic. Later on, the European mathematician Fibonacci converts that Arabic numbers to the European language or English language. Like this decimal value system translated to all over the world. Okay, here I have mentioned how it is translated. In Indian subcontinent, key development is decimal value system. Concept of 0 was there. Kutaka and Chakravala methods also discuss. Kutaka and Chakravala methods used in number theory system. Sine and cosine functions were there. The key features that Aryabhatiya, Brahmagupta and Bhaskara took during 5th to 12th century. They have contributed their work. The translation and expansion of this work during 8th to 9th century C by the Arabic Islamic word. Later on, it is translated by the European mathematician near about in after 1200 C.
Sir,
So as I told
can you wind it up in 2 minutes now?
Okay, sir. These are fundamental operations used here in the earlier mathematicians. This is the Kotaka solving intermediate equations that we have to find n. N is congruous to R1 modulo D1 and n is congruous to R2 modulo D1. So R1 and R2 are remainder, and you have to find the value of n satisfying these two conditions. So Aryabhatta during 5th C, he mentioned the original method. Here he used the Euclid algorithm, that back substitution method you can call it as. Okay, we'll see in the example. So this is the Kutaka algorithm. I will share this PPT to you. And this is numerical example to solve, find the value of n satisfying both of these congruencies. This is Bell's equations. Earlier it was known as Varga Prakriti equations. We have to finding the n square free positive integer for you have to n is given, positive square free positive integer is given, and you have to find the values of xy. This is known as the Bell's equations. But it was discussed by Bell's equations by Eulers, wrongly called Bell's equation by Eulers in 18th century. But if you see in the Indian literature, it was studied much earlier in India. That is in the Brahmagupta literature, Jayadeva literature also, and Bhaskara too also. So Farmas during 1657 he find x and y for this n61 and n equal to 109. Okay. Thank you.
Thank you, sir. Let me stop recording now.